Direct variation is a special linear function that crosses from the origin. So it goes through the origin, the y-intercept is the origin, and so it takes on the equation y equals kx, where k is the constant of variation, and k is the same thing as a slope. So what it looks like on a graph is direct variation always is a straight line and it goes through the origin. So k could be positive or k could be negative. On a table, you can tell if something's direct variation if these values are your x's and these are your y's. In order to get the y, you have to multiply the x by some k, the constant. So if x is 1, y is 3, x is 2, y is 6, x is 3, y is 9. In this case, k would be 3. In order to go from x to y, you're multiplying by 3. On a table, you can also tell because when you divide the y's by x, you always get the same number every time. So 3 divided by 1 is 3, 6 divided by 2 is 3, 9 divided by 3 is 3. Therefore, k is 3. In words, it's a proportional relationship. It's linear, and the y-intercept, the starting amount, is 0. The initial is 0. So example 1, determine whether or not this is direct variation. So you have a table. If it is direct variation, find the k and write a function. So the functions are going to take the form y equals kx, and you will have to determine what k is. So on this first table, what I do is I do y divided by x and see if it is the same for all three values. When I do negative 2 divided by negative 6, I get 1/3. 1 divided by 3 is 1/3. 4 divided by 12 is 1/3. Therefore, k is 1/3, and yes, it is direct variation. My equation is y equals 1/3 x. So once you find your k by doing y divided by x, that is your slope. So now letter B is negative 2 divided by negative 1, the same thing as 4 divided by 3. Is that the same thing as 7 divided by 6? No, it's not. So it's not even direct variation. And then the last one, 5 divided by negative 9 is negative 5/9. This one, I could work out the fraction, but I can already tell that it's not direct variation because in this case, the top number, k, was going to be negative. The middle number, k, was going to be negative. But in here, k is positive. So I don't even have to work out what these two are to see that it's not direct variation. In example 2, for each function, determine if it's direct variation. So does it take the form y equals kx? So this is y equals 1/2 x. So yes, it is direct variation. Your k is 1/2. When you solve for y, you just get y equals a constant number times x. There's no y-intercept besides 0. In letter B, we're going to solve for y. So I'm going to add 1. So it's 2y equals x plus 1. I can already tell this is not direct variation because of this right here. That's going to be your y-intercept. So no, because the y-intercept is 1/2. And then letter C, I solve for y, so I multiply both sides by 3. This reduces to 1/2. So it's y equals 5/2x. So yes, it is direct variation because it's y equals kx, and the y-intercept is 0. Number 3, the circumference of a circle varies directly with the length of the formula using the formula C equals pi d. So you have the circumference equals pi d. The circumference varies directly with the diameter. Should actually read that there's a diameter in here. Length of the diameter using the formula C equals pi d. What is the constant? So this looks very similar to y equals kx. This is your k. The circumference depends on the diameter. The y depends on the x. So your k is equal to pi. And then letter B, calculate their circumference to the nearest tenth, so 1 decimal, if the diameter is 3. So you do circumference equals pi d, circumference equals pi times 3, and then you're going to round that to the nearest decimal, 1 decimal. So more with direct variation. So we're going to write equations with this. So you know that y varies directly with x. If y varies directly with x, you can automatically write an equation, y equals kx. So step 1, you're going to write the equation, y equals kx. Step 2, you're going to solve for k. And write the equation y equals blank x. So over here, I'm going to use y equals kx, but this, when y equals negative 10, x is 2. This is the step that you're going to solve for k. So when y equals negative 10, x equals 2. So it's going to be k times 2. So k equals negative 5. So my equation is y equals negative 5x. That's my equation for the direct variation. Then the final step is plug in numbers into your equation. So my equation is going to be y equals negative 5x. Find y when x is negative 3. So y equals negative 5 times negative 3. Y is 15. There's my final answer. So I'm going to walk through the process for this last one. Y varies directly with x. Middle step, solve for k. Use this knowledge right here to solve for k. So k is negative 1/2. Write an equation. So y equals negative 1/2 x. This is the part that a lot of people miss when we were in Algebra 1 and also Algebra 2 is if you have to write an equation for the variation, don't skip this part. The equation for the variation is y equals with an x in it. It's not just y equals kx, and it's not just this part right here, it's this equation. And the last step is you plug in, find y when x is negative 30. So this, we're asking for y again, so find y when x is negative 300. I misspoke. Negative 300, so it's half of 300, so it's a positive 150. So we really want to have this equation just like how I had it right here. You had to find the k by plugging these two in.